Hello, and welcome to Backer Breaks It Down. In this episode, we continue looking at angle pair relationships with a focus on vertical angles and linear pairs. Linear pairs. Well, you have to have a pair of adjacent angles whose non-common sides are on the same line. So here I have a straight line, but it's also an angle, a straight angle, and it's been split into a pair of angles, hence linear pair. Now, the linear pair postulate states if two angles form a linear pair, then they are supplementary. So angles 1 and angle 2 form a linear pair. Therefore, I can say that the measure of angle 1 plus the measure of angle 2 is 180 degrees. So let's take a look at an example. Set up and solve a quadratic equation to find the value of x. Then find the measure of angle LIR and the measure of angle RIN. Well, those two angles form a linear pair, so that means they add to be 180 because linear pairs are supplementary. So that's our equation. So let's get it equal to 0. So now I'm going to have n squared plus 3n minus 180 is equal to 0. So this is an easy quadratic to factor. We simply need to think what multiplies to be 180 degrees and adds to be 3. So let's do some dividing. 12 and 15 work. So so it has to multiply to be negative 180 and add to be 3. So 15 times 12 is 180, and if the 12 is negative, I get negative 180 when multiplied together. So we're looking at n plus 15, and n minus 12 is equal to 0. So algebraically, there are two solutions. N can be negative 15, or n can be 12. Algebraically, two solutions. Geometrically, what makes sense? Does the negative 15 make sense? Well, considering one of our angles is 3 times n, the negative 15 doesn't make sense. So n is 12, which means that angle RIN is 3 times 12, which is 36 degrees, and 12 squared, well, that's 144. Okay, so we had a linear pair. Linear pairs are supplementary, means they add up to be 180 degrees. Let's talk vertical angles. Whenever two lines intersect, two pairs of vertical angles are formed. Okay, in this diagram here, angles 1 and 3 are vertical angles. Angles 2 and 4 are another pair of vertical angles. And the Vertical Angles Theorem says that vertical angles are congruent, so they have the same measure. So let's take a look at a problem involving vertical angles. That's what we have in number 5. Okay, so I know that 5x minus 2 is going to be equal to 78 degrees. And then I'm just solving this equation. So 5x is equal to 80. And then if I do some division, I get that x is equal to 16. In number 6, I've got a line that's been split into a pair of angles. So that's right, we have a linear pair. So I'm going to add those together, 7x plus 19. Linear pairs are supplementary, which means they add up to be 180. And so now I'm simply going to solve this equation. So I end up with 7x is equal to 161. And then if I just do some dividing, I get that x is equal to 23. So there you have it, linear pairs. See a line that's been split into a pair of angles? That's a linear pair. And linear pairs are supplementary, which means they add up to be 180. Vertical angles are formed by intersecting lines. They kind of make a bow tie, and those angles are congruent. And that's how Backer breaks it down.